Algebra 2 concept students. Today we're going to talk about rate of change and then slope. And basically, rate of change is what slope is kind of in the real world with some real world examples. And we're going to compare how much one quantity changes relative to a change in another quantity. And that other quantity is usually time. So these are exercises from page 17 in your packet. This is number 2. And as you can see, they're giving us time and then what the altitude of a balloon is in meters. So like after 3 minutes, the balloon is 520 meters in the air. After 8 minutes, it's 1220. So if we were going to find the rate of change, basically between 3 minutes and 8 minutes, we would find the change in the altitude of the balloon. So I would take 1220 and subtract 520, which gives us 700, and divide by the change in the time, which is 8 minus 3, or 5. If I take 700 and divide by 5, that goes in there 140 times. So this example, the rate of change would be 140 meters per minute. If I do this for some other units of time, let's say I want to use the 8, 12, 20, and the 15, 2200, then I would do the same thing. Our change in altitude, 2200, take away 1220, would give us 980, I believe. The change in time there, we're going from 8 to 15, so 15 minus 8 is exactly 7. And 7 is going to go in there also exactly 140, so it'd be meters per minute. And if all of these are the same and all of these different times are consistent, then it'd be a linear relationship. Next one here, this is number 6, talks about the time in seconds and the distance between two sleds. You can see here as the time is going up, the distance is going down. So we're talking about a negative slope or negative rate of change. If I do it the same way, let's say I work with these 3 points right here. I would take 30.2, take away 37.3, and the time in seconds would be 3 minus 0. So on the top, I'm going to have a negative change. It'd be a negative 7.1, and on the bottom, I have 3. And then I would divide those using a calculator, and you would get a value, which is going to be a negative, and I will, hold on a second here. So if I take 7.1 and divide by 3, I get 2.366, and in this case, that would be negative. Labeled, what did you subtract on the top? That was distance between two sleds. So that could be meters also, and then it would be by seconds or meters per second. And you could do the same thing using different points to do that. Next thing we're going to talk about now is slope. So slope is applying this to lines, and we're going to be measuring the steepness of a line. Slope is abbreviated by M, and sometimes referred to as the rise over the run, the rise over the run. The rise is vertical change, which is the change in the y coordinates. So we have y2 minus y1 over x2 minus x1. So the exercise on page 18, it's asked you to find the slope of a line that goes through these 2 points. So this means if I have the point 47, and just bear with me here, and 613, let's say it's approximately right there, we want to find the slope of this line. Obviously that line is rising from left to right, should be a positive slope. But using my slope formula, my change in y will be 13 minus 7. These are my y coordinates. And then my change in x would be 6 take away 4. And I need to subtract them in the same order that I do on the top as on the bottom. So I have 6 over 2, which is 3. Which means this line, I go up 3 and over 1, up 3 and over 1, up 3 and over 1. Number 4 here, if I'm finding the slope of here, I do my change in my y's. So it's 3, subtract a negative 3, chop chop, which is going to be 6. And then on the bottom, I need to do negative 4 minus the 5, which would be negative 9. Reducing that, it's going to be negative. That means the line will fall, and it would be a negative 2/3. Last example here, number 7, change in y. Again, I could do negative 2 subtract 3. Using these y coordinates, and then divided by the x coordinates in the same order, so it'd be 7 minus 3, which would be negative 5 over 4. Make sure you realize that if you would have done on the top 3 minus a minus 2, then you would have to do 3 minus 7 on the bottom. You're still going to get a negative 5/4 as your slope. The last part of this is find the rate of change when you're given a graph. When you're given a graph, you're going to want to locate 2 points that are on the line. So in this particular example, I'm talking about these 2 points. I can use any 2 points on the line. And then working left to right, we're going to do our rise. So going from point 1, the first point to the second point, you can see I'm going to go down 3. I'm going to go over 1. My rise is a negative 3, down 3. My run is 1 because I'm going to the right. So my slope would be a negative 3 there. In this example, I'm talking about these 2 points. This definitely has a positive slope. And I'm going up 3. I'm going over 4. Rise 3, run 4. So it'd be 3 over 4. 3/4 would be the slope of that line. So after watching this video, re-watch it if you need to, slow it down if you need to, and then you should be working on the 2.3 practice that's in your assignment packet.